Good morning, good afternoon, wherever you may be in your day. Part 3 of stoichiometry. But no fear, there will be a part 4. We're not done yet. Reactant to reactant focus today. Alright, so let's start out with a hard version of this. How much ammonia is left after the reaction of 10 grams of oxygen and 10 grams of ammonia according to the reaction above? Pretty straightforward. Again, a few things going on here. They give us an amount of oxygen. They give us an amount of ammonia. Those are two different chemicals. Again, I hope that strobe light's going crazy. Motomole, 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 motomole. Good, then you're good. We're on the same page. And you're thinking balanced chemical equation. And then you look up and you're like, this is fantastic. I get practice at balancing. This one's not even balanced for me. But I do have a reaction, so that's a good starting point. Let's take the most complicated thing up there and, I don't know, put a 1 in front. Balance the nitrogens. Nope, yup, nope, one other place. We need 1, sets of 1. Let's balance the hydrogen. We need 3. They come in sets of 2, 3 over 2. And of course that's a fraction. So let's multiply it through by 2. That becomes 2. That becomes 2. And that becomes 3. Lastly, we can do our oxygens. We have 2 oxygens here, 3 oxygens here. That's 5. 5 divided by 2. 5 halves, again, that's a fraction, multiply through, and we have 4 ammonia plus 5 oxygen goes to 4 NO plus 6 water. To give you a more challenging balancing, just a little bit of practice. And let's do the same thing I always like to do. 10 grams of oxygen, 10 grams of ammonia, and we're asked how much ammonia is left. So, this seems like we have information about this, but this is at the beginning. This is our starting point. So once again, the only piece of information we have to work with is another chemical, so that's a mole-to-mole ratio. And of course, if all else fails in chemistry, convert everything to moles. And you know I like to work backwards on my railroad tracks. So let's start with that 10 grams of oxygen up here. And see if we can compare that to NH3. So same mechanism we've been using. Get it to moles. We do have a relationship between grams and moles. That's our formula 8. We can grab it off the periodic table. In case of oxygen, it's pretty easy. Now we can use the mole-to-mole ratio of oxygen to whatever we care about. So converting from chemical A to chemical B, mole-to-mole ratio only comes from a balanced chemical equation. Hopefully that's becoming routine. And then we just find we have a 5 with the O2, leave the 5 with the O2. We have a 4 with the NH3, leave the 4 with the NH3. We have our moles of ammonia, grams to moles, that's easy, formula weight. I told you we'd do this a bunch. NH3, 17.04, and we can punch it through, and as I like to say, we get a number. And we get a number that's 4.26. And my question is, have we answered the question? Getting a little bit of a metacognitive question there. And we're asked what? How much is left? When we do a calculation that results in an amount of reactant, what do we actually calculate? Well, we actually calculate the amount that is used or goes away. So we have left over versus what disappears. Reactants disappear, we calculate how much goes away. Products appear, we calculate how much appears. Reactants down, products up. So this is how much we lose. Certainly not what's left. So if we want the actual excess, we need to take our starting amount and subtract our use. Not hard, but it is an extra step. There's 5, assuming I did my math right in my head, there's 5.74 grams of ammonia in excess or left at the end of the reaction. So just remember that extra step. Just really wanted to emphasize that in a video. that reactants are what disappears, products are what appears. And again, I hope on some of these things you're actually pausing the problems before I do them and see if you can work your way through, particularly if it's an extenuation like this. See if you can figure out that next step. Struggle with it, get it wrong, get it right even better. And then watch the video and go, okay, that's where I made my mistake. And it'll mean more to you as you go along. Be active. I hope you're taking notes. Oh, good. Nothing broke. Let's do one more example. And I might have hinted earlier that, again, pause, try this one. It's easy, I hope. Iron reacts with hydrochloric acid, produce iron chloride and hydrogen gas. How many moles of HCl will react with 3.5 moles of iron? And once again, I know I am being redundant. Two chemicals, mole-to-mole ratio. And if it's a mole-to-mole ratio, we need a balanced chemical reaction, which we do not have. But we do have. They just hit it. So iron is just Fe. And when people say it like that, they mean like the metal iron, just by itself. So you would just write it like that. Reacts with hydrochloric acid, probably dissolved in water. I'll make that assumption. You don't have to. You can just leave the states off if you want. And then that's iron, so that's Fe with a 2+ charge. Chloride Cl, I go to the periodic table. I notice it's 1 from the end. It's got a -1 charge. We cross that down. And we get FeCl2 aqueous. And then hydrogen gas is H2. And it says how many moles of HCl will react with 3.5 moles of iron. So once again, you can see two different columns. This is going to be mole-to-mole ratio. We need a balanced chemical equation. And some of you are probably going, Dr. Wirgo, you got to balance it. You are absolutely correct. Now we have a balanced chemical reaction. And do the same thing we always do. Put our railroad tracks down. Choo-choo. Put our moles of HCl up. Put our other piece of information here. And what do we do next? Well, we want to go from chemical A to chemical B. We need a mole-to-mole ratio, which means we need moles. And I hope I tricked some of you. We're already in moles. We don't have to go any further. Let's jump right into the mole-to-mole ratio. Moles of iron, moles of HCl, and then they ask for moles at the end. So we're done. I don't even need a calculator. The answer is 7. Voila. And we are done. Thank you as always for your time. And that's 7 moles of HCl that is needed to react or disappear. To contrast and compare that to the first reaction, or first question, where we did how much was left at the end. So 2 different calculations. They look the same. You have to read carefully and critically. Make sure you're doing that as you work problems. It's always good. Engage your brain. It's a good thing. And have a wonderful day.